Hello, welcome everyone. So today we are going to start a new unit, chapter 3, Introduction to Algebra. So we are going to cover two topics today. The first one is working with formulas, and we are going to learn about some terminologies associated with algebra, and we are going to understand how we can use those formulas and evaluate simple formulas. That's the objective of the first topic. So before I start the topics and go through my presentation, do you guys have any question, any concern? Anyone? Just type on the chat so that we can discuss about it. So I'll take 2-3 minutes on that. Then I'll start my presentation. And today we are going to cover 3.1 and 3.2. Okay, guys, so let's start our lesson. So the lesson for today, the first one is 3.1, working with formulas. We are going to see some terminologies in algebra, and also we are going to understand why we need those formulas. So basically the formulas to a formula, and also we'll see how to evaluate those formulas. Given some parameters, we can easily evaluate another parameter. So let's start. The first topic is relatively simple. The next slide is most important for me. So I want you to know the terminologies around expressions or equations or formulas. So these are the vocabularies I want you to focus on. And if you see on the right hand side, the definition of equation is it's a mathematical statement containing an equal sign. So when you see equal sign, it's called equation. If there is no equal sign, it's called expression. Numbers may be represented by unknown variables. So when you see a variable, something which represents a quantity which is unknown or which is a varying quantity. So variable is a varying quantity represented by letters like X, Y, or A to Z, any letter. We usually use any letter. So that's the first definition, variable. The next thing we'll look at is constant. Constants are numbers. For example, see in the equation 8 and 16 are constants. They are called constant. Numbers are constant, which doesn't change. These are quantities which doesn't change. So 8 and 16 may represent something. It can be, for example, distance or some time or any physical quantity, which is fixed in this case. The variables, those letters, they can vary or they are unknown quantities. The next one is coefficient. The coefficient is the number in front of the variable. The number in front of the variable. For example, if you have 5x, 5 is the coefficient. If you see here in the equation, we have 5x squared. So 5 is the coefficient of x squared. And we have 2x. 2 is the coefficient. So numbers which are in front of the variable are called coefficients. Next one is exponent. Exponent shows the number of times a variable or number is multiplied by itself. So that's basically the basic definition. If you want to know or if you want to identify the exponent, it's just the power over the variable. For example, x, the power of 2. So 2 is the exponent for x. So the exponent is the degree or the power over the variable. operators. We use all 4 operators to describe expressions. So the addition, subtraction, multiplication, and division. Those operators are symbols indicating what operation must be done. They are called operators. Now, terms. This is something we are going to cover in the next topic, but I will describe it in a short. So, one part of an expression, which may be number, variable, or product of both. Product of both numbers or variables. If you see here in the equation, we have 5x squared, 2x, negative a. So these 3 combined and they will give you something called expression. So expression is the combination of each individual term. So the terms are 5x squared, 2x, and negative a. Now, terms are separated by plus and minus sign. If there is no plus or minus sign, it's a single term. If there is plus or minus sign, they are divided. For example, if I say a 2ab squared c, even if you have 3 terms, 3 different variables, this is a single term, just one term. You have a, b, and c as a variable, 2 as a coefficient, and the whole expression is called a term. Now, if I add, let's say 11 b, now we have, okay, and let's say subtract 2ac again. So this is also another term. So terms are divided by either addition or subtraction. So the overall the whole expression, the whole thing is called expression. Expression. So individual expressions which make the overall expression are called terms. So terms are expressions which are separated by addition or subtraction. Okay, so these are the terms I want you to remember moving forward, because we are going to use them over and over. If I say variable, you have to know what variable is. If I say constant, you have to know what constant is. Constants are usually numbers, which is a quantity that does not vary or that does not change. Okay. Any question? Okay, so if you have any question, please write on the chat. I know this is just to introduce the vocabulary. Let's go to the next slide. Now, if you see in the next slide, we have example. Oh. So we have factors. These are numbers or variables which are multiplied to give you a single expression. So numbers or variables. To give you a single expression. A single expression. So if I am asked what are the factors of 2ab squared c, so individual a, 2b squared, and c are called factors. So each one of them. So this is factor of this expression. A is another one. We have b squared, and also we have c. So that's how you identify what factors mean. So if you see the next example here, for the expression 17 pi a d squared, what is the coefficient and which ones are the factors? So if you see, we have 17, which is a constant, so it can be a coefficient. But pi is also a number. Pi is not a variable, it's just a constant number. So the overall 17 times pi would be the coefficient. It's just a number. 17 pi is 17 times 3.14. And also the factors are, we have 17 by itself, we have pi, we have A, we have D squared. Each one of them are factors of this expression. So because they multiply to give you that expression. Any number or any variable which multiply to give you the expression are called factors of the polynomial. Okay. This is very simple, so I don't want to waste that much time on this. If you have any question, please write on the chat. We'll do more exercise as we go as we move forward. So next we'll see how we can use formulas to represent real world situations. So this is a very common geometry problem. So finding area of a triangle, can be a rectangle, can be square, any geometric figure. So we have different formulas we use to find area. So the first one is area of a rectangle equals the length times the width. So the expression is given in verbal statement. So we can use pictures here. Let's say this is L, this is W. So area is L times W. To find the area, we use L times 2. So these are called literal equations or formulas, literal formulas. So A is area, L is length, and W is width. The next one says volume of a cube equals the cube of the length of one of the edges. If you have a cube, and if you know one of the length of the edge, you can is the volume. So you have E here times E will give you the volume. So that's why we have E the power of 3. Area times height will be the volume. Next one is the pitch of a screw. So this is a standard formula for creating a screw thread. So the number of threads per inch will be multiplied by the pitch screw thread, and when you multiply the two, it will give you 1. They are inversely proportional. One is inversely proportional to the other. So that this is like standard unit for mechanical engineers to create a screw thread, so that if you have the right side, it should fit any screw. So they have some kind of standard. Okay. Next one is the distance is the average speed times time. So distance is speed times. So the formula says the distance of an object travels equals the average speed r times the time travel t. So when you multiply the two, you know the distance. So real world application, for example, if you know the time it took you to drive from, let's say, LA to Las Vegas, and if you know your speed, let's say you're driving by 65 miles per hour, and it took you 4 hours, you can easily calculate the distance from Las Vegas to California. You use the average distance, the average speed multiplied by the time it took you to reach to California. That gives you the distance between Las Vegas and California. So this is, Las Vegas and LA. California is a big state, specific city. So, for example, you can go to San Diego or California. So you can specifically answer the distance question. So it's like a real-world application. That's why we need these formulas. The next one is simple interest. So this is a very popular formula in finance. If you want to know the interest, if it is not compounded, but it's just a single interest per year, that means the interest is only on the principal. You will not get interest from the interest. So I don't want to go in detail. So there are some different compound interests. Usually banking use compound interest, but in some deals you get a simple interest. So the simple interest I is the principal, the amount you invested or the amount you paid, and let's say an object, you paid something with some principal value, and if it has interest, you pay the interest also. So the R is the rate of interest, and T is the time it takes to pay the interest. Okay. The next one, number 6, is a physics problem. If you have a voltage across resistor in an electric circuit equals the current I times the resistor R. So the voltage can be found by the current times the resistor. So the resistance in the wire multiplied by the current flowing through the wire will give you the voltage. Okay. So this kind of expressions are called formulas or literal equations which describe real world situations. So these are very simple examples. Now next we'll see how to use them. Okay, so that's the most important thing. How do we use them? So the first example here says, example 1, if the current in a certain electric circuit is 5 ampere and the resistor is 7 ohm, find the voltage. So what is given is here, current I equals 5 ampere. We have R, the resistor, equals 7 ohm. And we are looking for the voltage. Okay, so it's straightforward. The formula is given. The voltage is I, the current times the resistor. So I will multiply the current, which is 5 ampere, times the resistors, which is 7 ohms. So ampere and ohms will give you voltage when you multiply the two. And 5 times 7 is, so 5, and the unit of voltage is V. So we have 35 voltage. Just multiply the two, you get the voltage. That's why we needed the literal equation. Okay. Any question? I know this is very simple. So I'll do one more example, and we'll do one example as a class. Okay, let's do the next example. Okay, now use the literal symbol listed to translate a given statement into an algebraic formula. So first we do change the statement into an algebraic formula. Then we use what is given to find what is required. So the distance d, so when you change an equation into a formula, so when you change the statement into a formula, you have to use some symbols, okay, letters, which represent the variable. For example, the distance is the variable, change with time. So the distance d that's given, the distance is d. So I'll put distance is d. Falls due to gravity. So it falls, the distance is falling down. Gravity equals half. So it says equals. Then it is half times the acceleration in g times the square of the time it takes. So the square of the time, c squared. So that's the formula. So the distance d equals half of the gravitational acceleration times the time it took squared. Now the question says find the distance when acceleration is 9.8 and the time is 2.5 seconds. So all you have to do is substitute g and t. 1/2. Our g is 9.8 meter per second squared times t is 2.5 seconds squared. 2.5 seconds squared. So multiply the two, 2.5 squared. So 2.5 squared is, I think, 6.25. You multiply. So half of 9.8 meter per second squared times 2.5 squared. 6.25 second squared out. So I have meter now. So all you have to do is just multiply half of this. Half is basically 0.5. So 0.5 times 9.8 times 6.25, which is 30.625 meter. So let me explain what physically this means. If there is a, let's say, a cube somewhere here at the top, okay, somewhere here. Let's say it falls down a certain distance height d, and let's say it is here, okay, the same cube. Sorry about my drawing. Now the question is how far it goes down within 2.5 seconds. It will go down 30 meters within 2.5 seconds, 30.6 meters. So it fall down 30.6 meter in 2.5 seconds. So this is like a classic physics problem. Okay, if you know the formula, you can easily plug in the numbers and you can find the distance. Okay. Any question? That's why we needed the formulas. That's why we try to change the real world situation and represent them using symbols or variables to represent the situation in a formula, or we call them literal equation or literal formula. Now let's example as a class. I'll give you 2 minutes. Find the equation and find the volume of the given cube. Okay. Use the literal symbol listed to translate the given statement into an algebraic formula. So the volume V of a cube equals the edge E cubed. Simple expression. Find the volume when the edge is 4 inches. Okay. Finish this and type your answer on the chat. Excellent, Abhi. Excellent. Richard, your equation is good, but you have to change what is the third power means. You have to change it into a formula. So we don't need sentence anymore. Yeah. Excellent, Richard. Your answer is also right. Anyone with different answer? Good. Excellent. Now, so your answers are good numerically, but because this is a physical quantity, it usually has unit. Don't forget to put the unit. So if you see here, the unit is inch, and your answers are right, but keep in mind 64 does anything. 64 what? Is that 64 meter cube, feet cube, kilometer cube? So yeah, it has to be in. So excellent, the numbers are good. So first the formula V is e to the power of 3. That's the literal formula. That's the first thing you have to do. Then you plug in 4. So V equals 4 inch. Don't forget the inch cubed. So when you cube the number. 4 times 4 is 16, times 4 will be 64. And now inch cubed would be the unit. So volume. So if you say 64, is it 64 meter cubed? Is that 64 feet cubed? Is that 64 kilometer cubed or centimeter cubed? Whatever unit you use for distance. So that's why you have to specify the unit. Okay. So on units, if the unit is not given, try to see if it accepts the unit. Sometimes you may be asked, what is the unit? Okay. So in this case, because it is cubed, it is inch cubed. Okay. Excellent. So now let's move to the next one. Excellent. It has to be cubed, inch cubed, Richard, because it's cubed. If it is area, it would be inch because you're multiplying inch by inch. Okay. Okay, now let's go to the next one. Now we are done with the first unit. Sorry, the first topic. The first topic is easy. It's just understanding what formulas are applied for in math, in algebra, and why we need them. So just present real-world situations, like finding the distance of a falling object by using a literal equation or a formula, and find the distance it travels in a given time or in a given seconds. Okay, so that's why we're interested in finding formulas and working with literal equation. Now, in the next one, we'll go and look at basic algebraic expressions. We'll talk about expressions and recognize algebraic expressions, identify terms of an algebraic expression, simplify algebraic expression, identify polynomials, monomial, binomial, and trinomial. So just basically naming a polynomial or classifying a polynomial. So don't worry about what monomial, binomial, trinomial means. So we are going to talk about them. The next one is to identify the degree of a polynomial. How we can identify the degree of a polynomial will be one of the topics. Okay, so let's begin here. So I will start by giving you some vocabulary. So because this is a new topic, so you have to know the vocabularies we are going to use around here. So the first one is algebraic expression. What is algebraic expression? It is a combination of constants. Constants are numbers, variables joined by arithmetic operation. So constants or numbers and variables joined by arithmetic expressions are called algebraic expression. So for example, if I have 2x squared minus 11x, this is algebraic expression. These are numbers and variables combined by arithmetic operations like addition, subtraction. Terms are parts in an algebraic expression separated by plus or minus sign. So if you have algebraic expressions like this, those which are separated by addition or subtraction are called terms. So in this case, 2x squared is the first term, and this is the second term. So we have two terms in this case, 2x squared minus 11x. So expressions which are separated by terms. Next, we see like terms. So like terms are terms with the same variable raised to the same power. So it has to be the same variable and it has to have the same power. Expressions which have the same variable, for example, if I have 3xy, we don't worry about the coefficient. And let's say I have xy, negative xy. So the same xy and xy. So there are like terms. For example, if I have 2b and 11b, so these two are like terms. we have the same variable b raised to the same power. For example, if I have use different color, 2x squared y and 3x squared y. So the same variable x raised to the power 2, same variable y raised to the power of 1. So these two are like terms. For example, if I have 2 squared, this is not the same as 2x squared y. They are different. So the x is linear, which is degree 1. The y squared is 2, degree 2, or term 2. So because of that, it doesn't have any like term. It's different from 3x squared y or 2x squared y. Okay, so like terms are terms with the same variables, can have multiple variables, raised to the same power. So you just match each variable and see if they have the same power. Okay, now let's see this example. So it says how many terms are there in this polynomial? So 3y squared minus 2xy plus xy minus 2y. So if you see here, we have one term here, two terms, 3, 4, 5. So any expression which is separated by addition and subtraction gives you a term. So 3y squared is separated by subtraction from 2x squared, sorry, 2xy. So we have 1, 2, 3, 4, 5 terms. So this is 5 terms polynomial. And the next question says which one are like terms. So look at the first number, 3y squared, and we have something which is similar to 3y squared, which is just y squared. So 3y squared and y squared are like terms. The next ones are negative 2xy. I use different color now. Negative 2xy and just xy plus xy. So negative 2xy and xy. So the advantage of like terms are they can be added or subtracted. You can simplify the expression even further by adding or subtracting like terms. So that's why we are interested in finding like terms and identifying terms of the expression. Any question on this example? Okay. If you have any question, let me wait. I think people are writing. Oh, do you guys have any issue with the network? Please let me know if. Okay, maybe it's from my side. I don't know exactly. Okay. Okay, maybe I'll stop the video and let's see if it changes. Okay. What about now? Let's give it like 1 minute. Does it freeze now? Okay, guys. Just let me know whenever you experience any network issue, so that I can go back and. Okay, I will. So basically, what this example is, yeah. So I'll repeat the last example. So you have expression 3y squared minus 2xy plus y squared plus xy minus 2y. Now, any expression which is separated by subtraction or addition is called a term. So if you are asked how many terms are there, just look at the expressions which are separated by addition and subtraction. So I have 3y squared, one term, negative 2xy, another term, y squared, another term, xy, another term, minus 2y, another term. So when you add all those, we have 5 terms. That's why we have the answer 5 terms for the first one. Now the second one asks for which ones are like terms. So like terms are those with the same variable raised to the same power. If you see y square, we have another y square. So we have 3y square here, we have 1y square. So those two are like terms. And also we have negative 2xy and xy. So those two are also like terms. And the 2y doesn't have any like term. It's just by itself. It doesn't have any like term. Just by itself, the 2y, the last one. So that's basically what this example is for. Identifying the number of terms and identifying if two expressions are like terms. So we are going to learn how to simplify expressions in the next topic. Also when we see adding polynomials and performing operation on polynomials. Okay, that's why we are learning terms, expressions, like terms, stuff like that. Okay, now let's go to the next one. Now, in the next slide, we are going to learn how to classify a polynomial by using the number of terms. So we know what terms are, and we know how to count them. Now we are going to look at how we can name a polynomial based on the number of terms. Okay. Now, a polynomial is an algebraic expression consisting of a single term or a sum of terms. So it can have a single term or it can have a sum of different terms, each of which is one of the following. So the terms can be a constant in the polynomial. It can be a constant, or it can be a variable with exponent that is positive integer. So in the polynomial, you can have just a number, or you can have a variable raised to a positive integer, or the product of the two, product of a number and a variable. For example, let's say this is just 5. So the polynomial can be just 5. That's a constant polynomial. We call it constant polynomial. A polynomial can have a variable, let's say x squared, raised to some power. Or a polynomial can be the product of the two. So it can be the product of 5x squared. So each of which is one of the following. So the polynomial is an algebraic expression consists of a single term. So these are single terms. 5x squared, 5x squared are single terms. So when we combine those three, you have your polynomials. For example, if I have 5x squared plus x squared plus 5, this is a polynomial. So this has 3 terms. So you can combine the two here, and this is called a polynomial. So this will give you 6x squared plus 5. So this is a polynomial. Now, polynomial can be divided by the number of terms. So if the criteria is the number of terms to classify a polynomial, it can be a monomial. Mono means 1. So mono means single or one. Mono means 1. So this is a single variable. A single variable, a term. Not variables, a single term. It doesn't have addition or subtraction. So when you see monomial, it's just a single term created by multiplying or adding a number and a variable, or variables for that matter. For example, I can give you another example. I have 2a squared b and c. So we have 3 variables, a, b, and c. All of them are combined by multiplication. So in this case, it is a single term. So it is not multiple terms. So or it's not more than one term. It's just a single term. So the number of variable doesn't dictate the number of terms. Only if you have addition or subtraction. Binomial, by is 2. So when you see by, it means 2. So we have two terms. In this case, we have 8x and -2. So, or for example, let's say 3x squared plus 5. This can be binomial. So two terms. We have 3x squared, one term. 5 is another term. Okay. Trinomial is 3 terms. Tri means 3. Trinomials, 3 terms. So anything above 3 it's called polynomial. So polynomial is an expression or a polynomial with more than 3 terms. More than 3 terms. So for example, if I have -3x squared, no, x to the power 5 minus 2x to the power 3 plus 2x squared minus 5x plus 6. If you see this expression, we have more than 3 terms. We have -3x squared. We have 1, 2, 3, 4, 5 terms. These ones have 5 terms. If it is greater than 3, it's called polynomial. So poly means many. So when you see poly, means many. So we use many terms. Okay. So that's the first way to classify polynomial. Any question? Now we'll see the next, the second way to divide polynomials, to classify polynomials. It's called by the number of degree of the polynomial. So polynomials can be divided by the degree of the polynomial. So if you see the middle of the table, you have 0, degree 1, degree 2, degree 3, degree 4. Now 5 is a constant number. So it doesn't have a variable. That means it is degree 0. So you can carry 5 and 5x to the power of 0 are the same because x to the power of 0 is 1. So that's why we have degree 0. So degree 0 polynomial is called a constant. The next one is degree 1, or if you see, we have 3x. 3x, x to the power of 1. So it is called linear or degree 1 polynomial. Linear polynomial. It's a linear. The next one is degree 2, x squared. So the degree is here, x squared. So it is called quadratic. Quadratic. The next one is cubic, x cubed. You can see it here and here, and it's called cubic. So you need this table if you want to refer it back. So and the next one will be quartic, degree 4. So in this case, I'm not going to include degrees greater than 4. If it is greater than 4, usually we have quartic, then we have quintic. After that, it is just the degree. So if you have degree 6 polynomial, you just name it degree 6 polynomial. There is no special name. Those are special names. So that's why I have them in this slide. So the special names are constant for constant number, linear if it has degree 1, and we have degree 2, which is called quadratic, degree 3, which is called cubic, and degree 4, which is called quartic. Okay. Understanding the table is most important. If you understand this table, you can easily answer questions about the type of polynomial you have. Now, I'll explain expressions which are not polynomial. So for an expression to be considered not a polynomial, one, the exponent can be negative. So if you have a negative exponent, it is not polynomial. So first restriction is negative exponent. So for example, if you have x to the power of -2 plus 5x, so because of the -2, this is not a polynomial. So this is not a polynomial. Okay. The next one is if you have fraction exponent. Fraction exponent. If you have, for example, to the power of x to the power of 4/5 minus 3x plus 1. So this is not a polynomial. Okay, so because the exponent here is fraction 4/3, x to the power of 4/3, it's not a polynomial. And the last one, you have negative exponent, you have fraction. If the variable is in the denominator, it's also not a polynomial function. So for example, if I have 3/x squared minus 2x plus 1, this is not a polynomial. So the variable cannot be in the denominator. So not polynomial. Okay, so these are the three restrictions. If you know these three, you can easily identify a polynomial. Now we'll see with example how to name polynomials by using both the degree and the number of terms. So usually the degree comes first, then the number of terms comes next. Okay, now we have this example. So I'll do number 1, 2, and I want you to do number 3 and 4. So number 1 and 2 are easy. So first I'll figure out the degree of the polynomials. Okay, the degree is the highest exponent. I should have. Let me work on this first. Okay. Sorry guys. Let me work on this first, and then we'll do that example. So identifying the degree and everything. Now let's work this on this examples. Okay. So first example, identifying like terms. Like terms are terms with the same variable raised to the same power. The same variable, they have to be the same variable. So if you see 9a is not the same as 2a, so they are not like terms. But 2a is the same as 5a, so they are like terms. So these two are similar. So we have 2b and 5b. Okay. And the next one, if you see here, we have a plus ab plus 2a minus 3b. So a here and 2a are like terms. You can add them, you can subtract them from the expression. So a and 2a. Now I want you to find the like terms for the number 3 and number 4. Number 3 and number 4. Okay. Okay, Richard. So the first one is good, but the second one you have to pay attention to the expression, Richard. Excellent, Diana. Anyone? Deborah, the same answer. Very good. Anyone with different answer for number 3? Okay. Three. Almost all of you got this one right. Those who participated, negative B R and negative 5 BR are like terms. Okay. Now, if you see the next example, before we distribute, A minus B is common here. If you can get, if you guys can see it, you have it. So before we distribute this expression, we can say 5 A minus B and A minus B are like terms. Okay, so we can add them, we can subtract them. This is addition, so it will give you 6 A minus B. So the first one will give you, when you combine the two, give you 7B. When you combine A and 2A, it will give you 3A. When you combine negative BR and negative 5BR, you'll get negative 6R. Sorry, BR. Negative 6BR. When you combine these two, you'll get 6 A minus B. That's why we are interested in like terms. We can add them, we can subtract them, and we can simplify expressions. Okay? Any question? Is it clear now? If you distribute, yep, A and B, so the expression will be different totally. So before we distribute, 5A minus B is the same as A minus B, or technically 1A minus B. Okay, now let's go to the next one. First, let's identify degree of a polynomial. So degree of a polynomial, first I will talk about a term, if you have a term. So degree of a term first. So degree of a term, if it is a single variable, we divide them by single and, so in this case we have single expression or single variable in this, sorry. If you have single variable like x by itself, no other variable. If you have single variable, it's just the highest exponent. Just the highest exponent, okay, is the degree. Highest exponent. If you have multiple variable, if you have multiple variables, you add the exponent. Add the exponent. Okay. Now this is just degree of a term. Now, if to find the degree of a polynomial, it is the degree of a polynomial is the term with the highest exponent. So it is the degree of the term with the highest exponent. So for single expressions, what I have to do is, for example, here negative 3x squared, I will look into the variable. I have only x squared. So the variable is single variable. It's just the exponent will be 2. So the degree is 2. We look at the degree. For the degree, we look at the exponent. So this is degree 2. Now, if you have multiple exponents, you just add the powers or add the exponent. Yeah, for example, if you see here 2x squared plus times y squared, so this is just a single expression, okay? So the degree will be 2 plus 3, which is degree 5. So this expression has degree 5. And if you see the next one, we have 1, 1 plus 2, 1, 1 plus 2, which is 4. So it is degree 4. So the first one is degree 2, because we have only x and the power is 2. The second one, we have x and y. The exponents are 2 and 3. So these 3 are single expressions. Now, if you have multiple expressions or multiple terms, what you have to do is find the degree of each expression or each term and take the one with the highest term. If you see here, for example, number 4, first I want you to find the degree of these two, number 4 and 5. Just try to find using the definition I gave you, and then we'll do it as a class. So find the degree of number 4 and find the degree of number 5. And write the answer on the chat. What are the degrees of 6x cubed plus 2x squared minus 9 and 4x squared y squared plus 7xy minus 9? So give me the numbers. Oh, number 3. Okay, so in number 3, you look at the variables, okay? So we have x, is x the power of 1, so we have degree 1. We have y, is the power of 1, we have another 1, so we have 1 plus 1. And z squared, so it is 2. So 1 plus 1 plus 2 will give you 4. That's how we get degree 4. Okay, so 1 comes from x, another 1 comes from y, and 2 comes from z. So z squared. Technically, degree means how many variables do you have in the expression. That's why. Yep, good. Now to number 4 and 5. What are the degrees of those number 4 and number 5? 6. Okay, I see 6. 6. Anyone? Different answer. 5 and 6. Okay, good. Okay, good. I see what you guys are doing. Okay, good. Deborah, for which one is 8? For number 4 or number 5? Okay, number 4, 5. Richard, okay. Okay, good. So number 5 is 6. Okay. Now, okay, I have a question. Did you guys see the difference between expressions 1 to 3 and expressions 4 and 5? What is the difference between those two? Anyone? What is the difference between expression 1 to 3 and expression 4 and 5? Excellent, Norman. So number 4 and 5 are additions of different terms. It's not single term. So we have different terms. Excellent. So any other? So use your word to describe the difference between number 1 to 3 and 4 and 5. So if you see here, number 1, number 2, and number 3 are just one terms, single terms. But number 4 and 5 are polynomials. It's not a single term. It's multiple terms. We have 6x cubed, 2x squared, and 9. Now, if you have a polynomial, to find the degree, what you have to do is find the degree of each terms, then take the one with the highest exponent. That's what you have to do. Do not add them. Most of you got 5 because you added 3 and 2. That's not true. We don't do like that. So this is what you do. You take the degree of first. Let me use a space somewhere here. Okay. First, I'll take the degree of 6x cubed. Then I'll take the degree of 2x squared and the degree of -9, and I'll compare them. The one with the highest exponent, I'll take that as a degree of the polynomial. So this one is degree 3. The exponent is 3. This one is degree 2. And this one is degree 0. Now the highest exponent is degree for each term. So we compare the terms. The highest exponent is 3 in the polynomial. So this is degree 3. Okay. We take the degree of the term with the highest exponent. We don't add them. If it is addition, we don't add them. We add the expression if it is multiplication. I want you to see the difference between the number 1, 2, and 3 and number 4. So in number 4, we have addition, so there are different terms. So for each term, we will find the degree, and then we take the one with the highest exponent. Okay, that's the difference. Now, for the next one, tell me the degree now. If you understood number 4, tell me the degree of number 5. So I'll erase this and use space. What is the degree of number 5? Yes. Yes, Norman. Yes, Abby. That's correct. Excellent. So what you have to do is just, yep. Yes, Deborah. Yeah, so we add the first one, x squared and y squared. We got degree 4. That is the degree of the polynomial. So this is degree 4 because we have x squared and y squared. We have 4 variables. We have 2 here. Here we have 0 variables. So basically the degree is like how many variables you have in each term. So we take the one with the highest exponent, which is degree 4 in this case. Okay, that's how you figure out the degree of a polynomial. If it is a single expression, just add the exponent. If they are separated by addition, different terms, you find the individual terms and you take the one with the highest exponent. Okay, so when you do examples on practice assignment, I mean on my MATLAB, you will understand this, and it's really simple. Okay, now let's go to the next one, naming. So naming can be done by 2 ways. One, by using the degree, and the second one is by using the number of terms. How many terms do you have? Okay, now if you see number 1, we have 2x plus 7. So the highest exponent is 1 in this case because x has x to the power of 1. So degree 1 expressions are called linear. So this one has degree 1. So let me write 1 here clearly. If you have degree 1, it's called linear. Now the number of terms, we have 2 terms. One, -2x, the other one is 7. If you have 2 terms, it's called binomial. 2 means bi. Binomial. Binomial. Bi means 2. Okay, bicycles. So when we write the name of the equation, we combine the two, usually the name from the degree first. So this is linear binomial. Okay, that's how you name this polynomial. And I'll do number 2 and we'll do number 3 and 4. I'll give you time to work on number 3 and 4. And after that, I'll show you some application problems and that'll be the end of the lesson. Number 2, we have degree 2. The highest exponent is 2. Between the two, we have x, 3x, which is degree 1. So this one is degree 1. This one is degree 2. So this is degree 2, which is quadratic. You can check the table. Degree 2 is called quadratic. Okay, and the number of terms are again 2. We have one x squared, the other one 3x. So 2 terms. 2 terms are called binomial. You can see that the expression is binomial, similar to the previous example, but it is degree 2 and it is quadratic. So it is quadratic binomial. That's the difference. Quadratic binomial. Okay. Now I want you to try number 3 and number 4. Try number. Yeah. So for polynomial, we take the highest exponent. Yes, Sabi. The one with the highest exponent. We look at the variables. The one with the highest exponent is the degree of the polynomial. You're welcome. Now figure out the name of these two polynomials. 4x squared minus x plus 6. So let me remind you the table, the previous table. Now let me go over that very quickly so that you can see what we are doing. Here, first, if you have one term by itself, it's called monomial. Mono means 1. 2 terms, binomial. 3, trinomial. More than 3, we call them polynomial. The next one, the next table is for the number of degree. If you have degree 0, if you have a number, it's called constant. If you have degree 1, like 3x, it's called linear. Degree 2 called quadratic. Degree 3 called cubic. Degree 4 is called quartic. So just try to remember these names. They are special names. After degree 4, we don't have a special name. We have quintic, I mean, sorry, not quintic, but we don't usually use degree 5 or above. If it is degree 5 and above, just use the degree. So we can say degree 6 polynomial, degree 7 polynomial, like that. Okay, we'll go back to this, and I want you to give me the names. Give me the names very quickly. Anyone? Okay, good. It is trinomial. What about the degree and it is named depending on the degree? Remember, we have 2 names, not just one name. 2 names. Is it monomial? Is it binomial? That's depending on the number of terms. Is it linear? Is it quadratic? Is it cubic? Is it a constant? Cubic, trinomial. So I combined Norma and Abby. So Norma said because remember it is it is degree 2. Trinomial to the second degree. Good, Deborah, but second degree has a special name. So second degree is called quadratic. So it is quadratic trinomial. Okay, so this degree 2 is called quadratic again, similar to the previous one. So quadratic trinomial. Now we have 1, 2, 3 terms. So it's trinomial. Trinomial. Okay. This one is cubic. Degree 3 is called cubic. Degree 3. And we have 1, 2, 3, 4 terms. More than 3, we don't have special name. We call them polynomial. That means many. polynomial. We have a special name only up to 3 terms: monomial, binomial, trinomial. Okay, that's how you name a polynomial. So in your assignment, you may not be asked to combine the two. You may be asked individually. If you are asked to combine them, just combine them. Otherwise, this is a standard way we name polynomial: linear binomial, quadratic trinomial, cubic polynomial, like that. Any question? Yeah, it is cubic. Yes, normal. 4, 1 is polynomial. If it is greater than 3, it's polynomial. That's why we have cubic polynomial. Just combine the two. Again, Norma got the one with the degree, which is cubic, and Abi got the polynomial. So when you combine the two, it is cubic polynomial. Okay, next we have some examples. Changing expression into equation. Changing through algebraic expression. Given in a sentence, you can change it into expression. So this says a first number x, unknown number x. Just write unknown number x. Says equals the square of a second number, y squared. That's it. Very simple. X equals y squared. This is a literal equation. Okay, so or a formula. We call them formulas. So to find x, you have to know y. To find y, you have to know x. If you know one of the two, you can easily figure out the other. That's why we are interested in formulas. They give you some relation between different parameters. For example, between temperature and pressure, or between volume and also temperature. So they are important in finding different parameters in real life. And the second one is a total surface area A of a cube. So it says A of a cube, surface area A, equals 6 times the square of the length of its edge is squared. So to show you this physically, let's say I have a cube, okay? So the quantity we are looking for is the total surface area. Each area here, this area on this side, this area here, each one of them are E times E, which is E squared. So we have E squared on this side, E squared on the other side. We have two of them, E squared on the side here. We have E squared on this side. E squared at the top. On this side also we have E squared. E squared at the bottom. So we have 1, 2, 3, 4, 5, 6 E squares. Each side is E squared, E times E, because area is length times width. That's why we have 6 E squared. So the total surface area, if you are interested to find the total surface area, you have to find the individual areas and add all up, add them all. So we have 6 faces for a cube. Each area is E squared. So when you add them, so you have 6 E squared. That's physically what this formula tells you. Area equals 6 E squared. Okay. So you can change a real world situation into a formula. Okay, now let's see one more example, one more slide, and that will be the end of the lesson. We have 6 minutes. So let's see this example. So the next example is evaluating expressions. If you are given a formula and given some of the parameters in the formula, you can easily figure out the missing parameter. For example, in this example, we are given evaluate the formula P equals N times small p minus C. For N equals 8, P equals 250, and C equals 140. So I don't know exactly what this formula is in physically and in physics, but all we have to do is just use the number N and equals 8 and substitute into the equation. P equals N is now 8 times P is 250 minus C is 140. So P equals 8 times 250 minus 140 is 110. So if you multiply 8 by 11 is 88. So when you add 0, you have 880. I don't know the unit. It doesn't have any units, so that's the answer. That's how you evaluate expressions. All you have to do is just plug in the numbers where the given parameters are. N is given, P is given, and C is given. You can find the capital P. Any question? Okay, we have 4 minutes. I'll give you 2 minutes for the last example. This is a formula to change from degree Fahrenheit to degree Celsius. So we talked about degree Fahrenheit and degree Celsius when we talk about units. So degree Celsius is the international system of unit. Degree Fahrenheit is the US system of unit. So what is given is F, find C. So C equals 5 over 9 times F minus 32. So all you have to do is just plug in F and find C. Okay, so use the next 2 minutes and type your answers on the chat. Excellent, Abby. Anyone with different answer? So these are just evaluating expressions. So they are important when we learn about how to graph functions and expressions. So that'll be in the next unit. This unit, excellent, Jasmine. In this unit, we are going to deal all about polynomials. We do a lot of stuff with polynomials, multiplying, adding, dividing polynomials. So the only challenge is division, but I'll lay it out step by step so that you remember it for so long. So excellent, excellent. So you have to simplify it. Excellent. The answers are right. 20 is the correct answer. Okay. So let me go over and type that, and that'll be the end of the lesson. So C equals 5 over 9 times 68 minus 32. So 5 over 9 times 68 minus 32 is 36. So it's technically 36 over 1. So 5 times 36 is 180 divided by 9, which is 20 degrees Celsius. Excellent. So this is the lesson for today. If you have any question, we are open for 2 minutes. If you don't have any question, I will see you guys on Thursday. So we'll learn 3.3 and 3.4. Okay. So it will download automatically, the record. Yeah, when you go to my class, when you go to the link, it will automatically download it. Yeah, I started downloading. Sorry, I started recording. That's why we had a small glitch because of the recording. It's taking a lot of data, and I turned on my video also. That's why. Okay. So I'll try to record in different classes so that I don't want to disturb your class only. So next time maybe I'll record in another class or in another session so that we have a smooth class. Okay. Whatever assignment is due, it will include that, and I'll write that notification tomorrow. Okay. I'll write the notification tomorrow, Norma. So whatever assignment is due on that day, that is included. So I don't think I'll check 3.1. If 3.1 and 3.2 are included on the assignment for this week, you'll find that on the quiz. Okay, see you guys. Have a wonderful day, night, and I'll see you guys on Thursday. Bye bye.